Hey, what's up, guys? This is McLain Harvey, the managing partner for Glambot. And have you ever wondered what some of the differences are between a cobot and Glambot and how Glambot's able to get such smooth and precise shots? Well, a lot of it has to do with our motion control and motion planning software, but in particular, a technique that we utilize called velocity controls. This is Anujay Sharma, our lead roboticist and the mastermind behind switching Glambot over to velocity controls. In this week's episode of Glambot Talk, we'll dive into exactly what velocity controls are and why they're so critical in a live event environment. So let's go ahead and jump in. All right. Well, welcome, Anujay. Anujay is our lead roboticist here at Glambot. He's based in Sacramento, so he works with the robot every single day alongside our hardware team. And he's the mastermind behind our newest software update, 0.8.x, which is a huge leap forward, especially in terms of smoothness. And a question that we get a lot from our current owners and potential owners who maybe own a cobot and they're thinking about purchasing a Glambot is, how do we get it to look so smooth? It's that like fluid shot that is a signature of Glambot. So I just want to talk to you about the motion planning space, the motion control space, and in particular velocity controls and what velocity controls are and why it's important in live events and cinematography.
Sure. So when I joined in, like a robot was using position control for all the path execution, and we saw like a problem like where it would like shake sometimes or like make weird motions. But like the crux was like most robots that come with position control, including some of the cobots that are off the shelf of the market, they are there because the industry requires them to be that way. For instance, when I was in the welding industry using some robotic arms, they wanted to be really precise on the spots where they were welding, and you cannot be like off by more than a millimeter because otherwise you'll mess up the product, which is welding on the line. So for them, like position plays a really important role in their manufacturing process. But you also have to understand like the position control is in a very specific kind of environment for them. Like they control all the parameters for their environment. They control the weight of the payload at the end of the arm, and they calibrate the arm accordingly, and then they use it for like mass manufacturing. They never change the tool at the tip. They never change any of the environmental parameters around their factory, so it's always the constant thing which was calibrated at the beginning. But for our customers, like anyone can use like a GoPro, or someone can also use like a DSLR. Like it's like a varied sense of like parameters. Someone could have like problems with different environments. Like in Texas, there could be a lot of heat. Someone could be in Michigan or Chicago where there could be a lot of cold. So like we don't want them to like calibrate their robots depending upon the payload at the very end, nor do we want them to like have like extremely precise control at the very tip of the robot, because when you're trying to achieve this very precise control at the end, it causes like jerky motion in case like one of the motors does not achieve that specific target because of the momentum of the robot. It causes the whole robot to shake. So for that, we needed to switch to velocity control, because for the motors, we did not want them to achieve targets like point A target to point B target, but we wanted to tell them like how to achieve those targets. So we don't tell the motors like go from A to B and let them decide, but we tell them like how to go from A to B, and they simply execute our commands, which is like better for the flow state of the robot. And then, as we have seen in the recent tests and from the feedback from customers, it's now like so super smooth, flows like butter, and amazing for execution of videography.
Yeah, so correct me if I'm wrong, but position control is basically telling the robot go from point A to point B, and the robot pretty much goes to that point in a straight line. Whereas velocity control is telling the robot go from point A to point B, but here's how I want you to go from point A to point B. So it's almost like getting to the end goal is important, getting to the target's important, but it's also important how you get to the target. And velocity
Exactly.
control allows for that. Is that is that correct?
Exactly. So in velocity control, we calculate all the parameters like taking into account what kind of motor efforts we have, like how well they can accelerate, how well they can decelerate, and accounting all of that, we tell the robot how to go from point A to point B, which is like way more complex at the back end, but we do all the calculations at the back end. And
Yeah,
then the user can just like execute and press the start button and it goes like that.
you did all the heavy lifting for them. Can you maybe
Exactly.
talk about Cartesian space versus how we do things?
Sure. Like a lot of these cobots also do planning in the Cartesian space, which is basically the 3D space around you. So when we tell a robot to go from point A in the 3D space to a point B in the 3D space, it probably just goes in a straight line or does the planning in that 3D space. Now, like it's okay to plan in that space, but it also causes a bunch of like weird or like clunky movements on the robot because it's easier for the like for us humans to like see like how to go from point A to point B in the 3D space, but for a robotic arm which has like multiple joints like 6 degrees of freedom, how would it like go from in the 3D space in a smooth fashion, right? So like that's why like you see like weird motions for some of these robotic arms when they are taking like videography shoots or some kind of shoots. So the solution for that is to like plan in the joint space, which is basically we plan individually the motion path for each of these joints, and these joints then like execute a trajectory in this space, which is way more complicated. It's like 6 degrees of freedom. So for instance, like we can see like a single line is like 1 degree, like a plane, like you walk on earth is 2 degrees, and then if you see above like an aeroplane is like 3 degrees of freedom, but like 6 degrees of freedom is not even imaginable to a normal human being, and we are planning in that space.
Yeah.
So it's much more like easier to plan in that space for the robot, but for us like it's like way more difficult.
Yeah, yeah, that makes sense. Why I see certain shots and they look really mechanical. They look robotic because it's just telling it go point A to point B. I don't care how you do it. And then I look at our shots and I'm like, wow, that looks so much better because it looks like this fluid, natural movement. Um,
Mhm.
because it's allowing for arcing and curvature and all of these different degrees, like you said, it's 3D or 60, and 60 is just like this amazing shot. So yeah, whatever you're doing is working, so kudos.
Yeah, thanks. It took a lot of effort, but for us, like, we don't want to push any effort to the customers. So, like, we did all the hard work, and now it's only for the customers to push the start button and start executing some paths.
Yeah, that's well. I know our clients definitely appreciate that. Can you maybe talk about why velocity controls in a live event environment is so important? Because I know that you kind of touched on it a little bit. Like even temperature can change the way a motor performs or is tuned. Um, but I know there's even more behind that. So can you peel that back a little bit?
Yeah, sure. So when we are dealing with velocity control, we are just sending it velocity profiles for each of the motors, and then the motors simply have to follow that velocity profile and execute the motion. Whereas when we are dealing with like position control, we don't give the motors a velocity profile. We give them a target. And if they don't achieve the target, they can like go into error or stall. And for that reasons, like we need to calibrate the like the robot itself, or if we change the weight at the end of the arm, we need to calibrate it again. If there, and once we set those parameters, like there could be like some other variations as well, right? Where we calibrated our robot, we probably calibrated the robot in our warehouse, and now like someone's using it outside in like Houston, where like there's like sun on top of your head. Like those things could change over time. Like I'm not saying like it could create a lot of issues, but it could create these small issues where your output would not be that great. So when we have like velocity control in our hands, like we can like give it a bunch of like parameters, and be relaxed with the consequence of those parameters, because we are at the end of the day telling the robot how to move anyway, right? So we are controlling all the output, so we can be more dynamic in our approach and like account for all of these like external noises that are coming into the system, and still be like giving out smooth shots.
Yeah. So it sounds like it's a lot more flexible. You can interchange cameras. You can be in different weather environments, even on different grounds could affect it, the micro vibrations. And because we're on velocity controls, it handles all of those things in stride and still produces a very smooth path and movement. So
Yeah,
that's awesome.
even different speeds. With the new update, you can have different speeds as well.
Yeah, that's very cool. Do you think there's anything else regarding velocity controls that our owners or a potential owner might want to know or be interested in?
Sure. I mean, like at the end of the day, like velocity control for them is definitely gonna produce like butterflow paths. Like these paths are gonna be so smooth, like you don't have to worry about like shaking or like any kind of noise to the camera. It's and you can have like different payloads as mentioned earlier. That's also nice. You can have different speeds, and in general it's also like more reliable from the robot's perspective, because since we are controlling all the motors and sending them all the trajectories, there's less mechanical wear. Like if they were using like position control, they would jerk or they would shake, which would cause the motors to like shake as well and reduce their mechanical life. So not only are we like improving the paths, we are also like trying to improve the life of the robot itself. So you can use it for more cycles than it was intended for. So that's also a nice thing.
Yeah, that's a cool feature. Everyone likes their equipment lasting longer, I
Yep.
think. Awesome. I know that you're working very hard on our next software update, and we have some pretty cool features coming out. Anything you can leak to us on what might be coming down the pike?
Yeah, I mean, we've been constantly like dwelling into customer feedback, and I've been getting a good response for them. And then that's why we're trying to improve our product day by day. And we have like some ideas down the line and some new updates where we would probably be moving towards transitioning from one path to another path. And it might be like, or even multiple paths actually, somewhere on the idea of like tethering some paths together. So it's going to be like exciting. Probably at the expo we might see some new updates.
Cool. I love that. That's exciting. Well, I really appreciate your time, Anujay. Thank you for hopping on with me. And I guess I'll see you very soon next time I'm in Sacramento.
See ya. Have a nice day.
All right.
And
Thanks for listening to this episode of Glambot Talk. For more information on Glambot, please visit us online at getglambot.com.